Let me share my screen. Okay. All the steps are same. Like you need to go for new project and give the name for the file, that is multi power supply. Then save it. So in description, I will provide like 5 volt, 9 volt, and 3.3 volt. So these are the power supplies we are going to design. So this is our schematic. Firstly, we need to change this, like rename it with schematic. And save it. To design the DC power supply, we need a DC jack. So to get the DC jack, you need to go for E library. So in that E library, scroll down. So search for the DC jack. This is our DC jack. I'm taking this T20 DC jack and place it. And we need a connector, 3-pin connector for giving the input supply. This is the header and this is the connector. This is the 2-pin connector and this is the through hole 2-pin connector. So select that and place it here. So flip this. You have an option called flip horizontally. So select that. And to filter the noise coming from this power supply, we will connect a capacitor, that is electrolytic capacitor. So make sure that your capacitor is a through hole capacitor and rotate it so that the positive terminal is connected to the first pin of your whatever power supply you are going to provide. And to this DC power supply, we are going to connect a LED to check whether our input is coming or not. And for that, we are connecting LED. This is our LED. You can take any color and it is 3 mm and 5 mm. So I will take a 3 mm red color. Again rotate the LED so that your cathode is downwards, facing downwards. Now the connection has to be made. That is third and second pin are shorted and connected to the ground pin. And again your second pin of the connector is connected to the ground. And same here, the cathode of this LED is connected to ground pin. So do the connections like this. So the capacitor will filter the noise, whatever noise coming from the input. And this is the DC power supply. So for this DC power supply, we will name it as its output. This is the output where you will get your DC power supply. So the DC power supply has like very high voltage. So this high voltage has to be converted to 5 volt and 9 volt and again 3.3 volt. So that whatever is our need, we can get that much of voltage. So we will name this as a VIN. So this VIN is connected to, like it will be the input for the other voltage inputs, like whatever we are going to design, like 5 volt and 9 volt voltage units. For that, this output of this DC power supply unit will be input. I will name it as V in. This is the special function, that is the net flag. So no need to connect an extra wire, and you no need to connect an extra wire to the whatever units you are going to make. You can directly name them by using this net flag. If you name the name here, you can use the same name to rename there. Like I will show you how to do that. This is the power supply. So in next we will be designing a 5-volt voltage regulator which provides a 5-volt output by getting a input from this DC power supply. So for that we need a 7805 IC which gives a 5-volt of output. For that, let me type 7805 here. This is our 7805 TO220 pack. So you need to select that 220 pack. There are many packs. We need a 220 pack. So select that and place it somewhere here. And again, for this voltage regulator, we are going to connect two more capacitors. The capacitor will again do the filtering here. So firstly, I will connect a electrolytic capacitor. So why electrolytic means the capacitance of electrolytic capacitor will be like somewhat high as compared to the ceramic. So these are our ceramic capacitor. For smaller capacitance, we go for the ceramic like 0.01 microfarad and for the higher values of capacitance, we go for this electrolytic capacitor. So this is the connection, and again to get the output we will be connecting a connector, that is 2-pin connector. Through this connector we will get the 5-volt output. So let me connect them. Okay. So the input for this 5-volt voltage regulator will be the output of your DC power supply. This is your DC power supply. So whatever output is coming from this DC power supply, the same input goes to this 7805 IC. So for that again go to net label. This is the net label and place it on the this line. So no need to connect an external wire from here to here. You can directly name them so that they will be internally connected. This is the use of net flag. It will make sure that like your schematic will look more neatly. There will be no wires, like complexity will reduce. Okay. Now I will go for a 7809 voltage regulator. For that I need a 7809 IC that is not there in your E library. So you need to find it in your global library. Just to type 7809. This is the 7809. If you don't want this, you can go for others. So this looks nice. Like it has same schematic, like same symbol as we have already placed this one. So I have selected this. Now again I need two more capacitors. So I will rename this. This is the 10 microfarad and this is 0.01. And again, you can copy these capacitors only. Just press on the capacitor and press Ctrl C and press Ctrl V. The capacitor will get copied. Again, press on this. So this capacitor will get copied. And we have a connector again. So connect them again the same way as you have connected the above one. Whatever ground you are provided here, that should be connected to the ground. So select the ground from the wiring tools and connect it here. And this is also ground. Again, we have ground here. We connect all the grounds. Then again go to the net flag, net label, and again name it as VN. So this VN and this VN will be internally connected. So this is our 7805 voltage regulator. Lastly, we have left with a 3.3 volt voltage regulator. For that, I need a LD33 regulator. So press LD33 here. So this is the LD33. Double three indicates a 3.3 volt which gives an 3.3 volt of output. Select the one which has a proper schematic as well as the footprint. You can select any one of these. Both look similar. Okay. Switch. Again, the same connections has to be made. For that, again, copy them. Similar connections are there. So you can drag it and make it a smaller schematic. Now again, the input has to be given to this from this net label. So this is the schematic of our multi-power supply. Multi-power supply means we are getting different voltage outputs. This is for 5 volt and this is for 9 volt This is for 3.3 volt. Okay. Is this clear?
Yes, ma'am.
Okay.
Ma'am, the 7809 IC is for which power supply?
For 5 volt, like to get the 5 volt, 7805 IC is used.
And 7809?
It is 7809 for 9 volt voltage regulator.
Okay.
So the last value indicates the output voltage of this regulator.
Okay.
Okay, this is 3.3 volt.
Oh.
So we can make an individual block of this, like we can make the individual blocks by connecting a rectangular here. So it looks more neat. And you can make this as a dashed one. For that you need to select this and go here. There are options called stroke style, solid, dashed and dotted, and I can select dashed one. And let me keep them together. And this is the schematic of multi-power supply. So I left the ground. Let me connect it. So the voltage regulator works like first pin is our input, second is our ground, and third is our output. The input will be connected to the input of this 7805, and output will be taken from this output pin, and the ground will be connected with the ground flag. I guess the naming of the pins is wrong here. Let me see with the. So it is correct. Like the third pin is a input and first pin is a ground and second pin is output here. So it has different pin names. So if you want to reduce the schematic width, select the schematic and at the right side you can reduce its width and height. So make it as 600. Then 50 is right. And I can reduce its height to 500. Okay, I will name it as a multi-power supply. For that, select the text from the drawing tool and rename it as multi-power supply unit. And if you want to change its color, again you can change it here. And you can change its height, like its font size. And I will rename the individual blocks by again selecting this text. And this is our DC power supply. I need to reduce its font size and keep it as blue color. And the second one is a 7805. And you can copy this and paste it here. Like this is our 7809 voltage regulator. Just change the file with names. And this is our 3.3 volt. If you want to drag, like you want to increase its rectangular size, you can drag that. Size will get increased. Okay. This is LD33 voltage regulator.
Ma'am, LD for
LD334 3.3 volt voltage regulator.
and LD for
LD, like its full form.
yes.
Oh, I need to search, I don't know its name.
Okay.
Let me see. Load drop. It's load drop voltage regulator. Okay. So save the schematic and go to the design, convert to the schematic to PCB. It's showing like there are some unfinished nuts. Let me check. Okay, I missed one connection here. So this is the advantage. If you missed any connection also, it will show you where you have missed that connection. So it has to be connected to the first pin. So again save the schematic and go for design and convert to layout. And let me make it as round rectangle. And starting point is again 0, 0. Let the width and height be same now. We can change according to our requirements later. So press K to fit the window. Firstly, I will design the DC power supply, whatever I have here. For that, I will select save this layout. And if I go and select this here, the whatever components are present in this DC power supply will be get selected here. So you can easily differentiate them from the others. Okay, sorry. These are all the components. Again, we'll save it and select all the components here. This is the DC chart. This has to be connected at the like border. This is our 2-pin connector. So as I told you that the two lines should be facing towards your border line. This resistor is at the output side, and so we have capacitor, resistor, and LED here. So capacitor has to be kept here. LED is here. So this is the DC power supply unit. Now I need to go for the 7805. Okay. So I will select the 7805. All the components are selected here. I will drag it into my layout. So again, the P2 has to be connected at the border side. And this is our U1, that is 7805 voltage regulator IC. And this is the electrolytic capacitor. This is the ceramic and this is the electrolytic. So maintain some minimum distance between the capacitor like components, and the two lines whatever you are seeing that should be facing at the border. So because the voltage regulator will dissipate some heat, so if it is facing at the inner PCB, like all the components may get burned. So make sure that it has to face at outwards. So whatever heat has dissipated, it will go outside and it will not damage our components. So I got a cross mark here. So I have rotated it. So to remove that cross mark, you can rotate your symbol like this. And this is the components of our 7805 voltage regulator. So I have connected two capacitors, one IC and one pin like connector. And again, I have a 7809 voltage regulator. For that, again, I will drag the components. Firstly, let me place the 7809 IC. So it has to be again facing to the outer border line. I will connect the capacitors here. This is the 7809 voltage regulator. So I left with a LD33 voltage regulator. So let me complete that. This is the pin I will connect at the border. And this is my LD33. So I left with some space. I can change its like layout border by selecting by going to the tools and going to the set border outline. I can reduce its width and height. Can see that the width has to be reduced. Like I will reduce by 10, make it as 77, and height as 45. So it has got a rectangular shape. So to get the like round rectangular, again go to the set border and select a round rectangular option here. If you are comfortable with the height, you can select that only. But in my case, I will reduce it further by 42, and again I will reduce its width by 72. Apply. This is fine. So for mounting purpose, I will place the holes here. Sorry. This is the hole. Select the hole and place it at the corner. Now we will go with the routing. For that, select the bottom layer and press W key. If you want to change its width, I suggest you guys that to go for 1 mm track width for this DC power supply because the voltage what is supplied by this switch will be very high. So go for the 1 mm track width here. So in these cases, you can reduce that because the voltage is somewhat low here, like 5 volt, 9 volt, and 3.3 volt. That is like less as compared to the voltage that you are getting from this DC power supply. So select track width by pressing tab key. I will make it as 1 mm. So if you want to change its orientation, you can press space. So avoid all the 90 degrees in your layout. Don't make a 90 degree like this. You can make 245 degrees. Connect all the connections, whatever the easy connections you find. First complete them and then we can go for the complexity. If you want to reduce your width, you can reduce now because all the DC power supply components are routed. But if you don't want, you can go through the 1 mm. If you don't practice, you will be not get any skills of routing. So make sure that you are going to home and Just do practice this routing whenever you get time. Please do that. So for this, I will reduce the width by. I will make it as 0.9. 0.9. I will make it as 0.7. So you can see the width has got reduced. So I
Ma'am,
need.
you know how much is needed?
Sorry.
How to know that how much width is needed?
So you should be knowing what is the current flowing through this track.
Okay.
So according to that, we have many tools like you can enter the current flowing through these tracks. So it will show you the width of that track that the minimum width has to be maintained.
Which tools?
So I will find that and I will send the link into the group. Okay. There are
Okay.
many tools. I need to find one. Okay.
Okay, ma'am, please send that then.
Yeah, please. I will. So if you want to connect these ground pin to this ground pin, you can directly connect this or you can short with this track. Again, this is my ground pin. I don't have any track here to connect this pin with this. So I will go by connecting here. You can short this here. Again, I need to connect this pin with this. So you can find an alternative here. You can see that this track has got connected with this track. We can connect this track with this. You can see that you have got a track here. So by this, you can reduce the using of this top layer routing. Yeah, again I have to connect this here. I need to connect this line with the C3. Let me see how I can connect. First, let me finish with the all the easy parts. So this line has to get connected with like this line. For that, I will short it here. You can see that that line will go. Let us go from the top side. This is my VN pin. It has to be got shorted with the VN pin here. Let us see, is there any way? We can see this is the ground and this is the ground. You can connect the ground line at the bottom side. You can short this. So we left with three connections. This ground has to be shorted with this. We have connections. You can do the connections here. This is also my ground pin. You can short these two pins. We have two connections here. This ground has to be shorted with this. I have no any other options. So for that, you can make use of the jumper. Jumper means you will be connecting the two wires in bottom layer only, but you can't cross this line. So you need to take a wire. If you select a top layer, the automatic wire will get created there. And again, go to the bottom layer and short it here. Whatever hole you are finding, this is your wire. It will connect your bottom layer track with the top layer track. So this is the
And
function.
can we complete that in top layer only?
Yeah, you can complete the according to the way you are placing your components. You can do that.
Means the orange line can be completed in top layer only?
Yeah, this
Okay.
is the red. This is the red line. The red line indicates the top layer, and this bottom line indicates the
Means
like.
before merging to the previous line, you selected bottom layer. That's why I'm asking.
Yeah, like all the routing has to be done at the bottom layer. But in this case, what happening is I can't take the bottom layer. Like it will get shorted with this VN. So I am taking a top layer. This red color indicates the top layer. The bottom layer is connected with this top layer by using this wire. If you want to connect all the like if you want to do all the connections in the bottom layer itself, so you need to change some orientations of these components.
Yeah, that I know.
Yeah, by that way you can you can do that all the connections in the bottom layer. Okay, so again I need to connect a jumper here. For that, select the bottom layer and again select a top layer just to cross this like bottom layer tracks, and again select the bottom layer and go and connect here. So this is the connections. You can avoid these wires like wires. If the wires are high in your PCB designing, the cost will get increased. So try to reduce the wires as well as these jumpers. Do all the connections at the bottom line only. So then the cost will be less according to the cost you are going to get from this PCB. The layout and choose the footprints to know whether they have the 3D models or not. Before that, let me name it in the option clear as a multi-power supply. Okay, then save again and select any one of the component and go to the 3D model. The whatever cross mark is shown here that the components have no 3D models. So select that component and at the search you can type the part name like LD33. So in the user contributed, so there is no 3D model for this LD33. You can see by going to the Chrome, you can see that LD33 has the same 3D model. This is the LD355, LD33 3D model. Again, you can go to the 7805. It is also the same. The 3D model are same. So I will, for the showing purpose, I can select a 7805 3D model here. Press auto. Select a proper 3D model. This is the 7805 3D model. And every IC it has given written as 7805 only. Again search with other namings like LD33BT. 3.3 volt. Okay, let me find. Just type voltage regulator and search. So for the symbol purpose, I will select this. The units are in mils. Let me increase its height and width. It is very high.
Ma'am, what is mil?
Mil is a unit like if you have millimeter and mil and inches. These are the like units for the calculating your distance, whatever it may be.
Okay.
It has some relations like 1 mil equals to some millimeters like that.
Okay.
So you can change its units also, but in this case they have given. So if you want to change to inches, you can You have to like 2 inches, I guess. But it is taking in terms of mils only, so let it be in mils. So its width is correct. You can increase its height. So I need to change its orientation. And it's 90. The orientation is correct now. And I will make Z as 3. And scroll upwards. The wheel is very small. For that only the symbol is not moving, like it is moving very slowly. Mm. This is the symbol. 50. So the pins are not properly like sitting into this. We need to increase its width and then check whether they are sitting properly or not. Again, I have to make it as some 300. Now it has like this sitting properly. Or if you want more, you can make it as 400 and then check. This is fine. Then update it. Then again go to this P0220. This is my 7809. It has got some 3D models here, but that are not proper 3D models. They have some different models. Okay. And again, you can do any dummy 3D models. Okay, this is fine. So let me change its orientation. The IC gone at the bottom side, so make it as 270 and Z to 300. 300 is very high. You can increase its height or width. Okay, update this. So whatever two lines you are finding, that should be like this white line should be at the two lines. And update again. Save your layout and go to 3D model. This is the 3D model of your multi-power supply unit. So you can get the output from here. The P3 indicates of 9 volt and P4 is for 3.3 volt. P1 is for 5 volt and P1 has to be given to the input. Is this clear? If you want to take snap of this schematic, you can take and you can design the schematic as well as the layout. So by tomorrow, not tomorrow, in the next Saturday, we will design IR sensor and a relay module. So before that, complete these two activities: design of the like 555 timer circuit and this multi power supply. Okay.
Okay, ma'am.
Yeah.
Ma'am, what is prototyping?
In this case, prototyping is nothing but doing a prototype of your circuit by you
Means
need
how
to
to
have
develop a circuit from prototype.
circuit from prototype.
Means how to develop a circuit from a prototype.
So which prototype you are talking about?
Means what is the meaning of prototyping?
So prototype, according to me, like it will be having some like connections and some like components. According to that, you need to design your schematic, I guess.
Okay. Means is a layout.
This is schematic. The one which we have done now, like this PCB is your layout, and this is
Prototyping
your
is
3D model.
prototyping means schematic or layout.
This is, I guess, this is schematic only. Like you don't call it as prototype.
Okay.
Doing connections and all is like prototype, right? According to me, I don't know.
Okay, ma'am.
Yeah. Do you have any other questions?
Ma'am, when will discuss be uploaded?
This class in 2 days. I will inform sir today.